So, our first topic is logarithmic integration. So, what is logarithmic integration? So, logarithmic integration applies when you see a function 1 over x. The rule is simple. The integral of 1 over x is the natural log of the absolute value of x plus c, where c is the constant of integration. This is our formula, where u can be any function and our u represented by x should not be equal to 0. So, if we understand now the concept of logarithmic integration, let's now move on to solving. So, our first topic is logarithmic integration. So, when solving logarithmic integration, we just need to follow this formula. We have this integral of du over u will give us the answer of ln absolute value of u plus c. So in order to solve problem involving logarithmic integration, we just need to follow this formula to get the answer. So our first example is we have here dx over x. So we can use this formula to get the integrand of this equation or function. So we have let's put 1/2 outside of our integrand. Then we have dx over x. So we can use this formula now. So we have 1/2 ln x plus c. So we have this as our answer. So if we integrate this, we will just get this answer, because this is just the derivation of this function. So if this is the integration of this function, so the main idea of integration is just rewriting the derivation into its original formula. So that's the main idea of integrating a function. So let's move to our next example, example number 2. So if you are confused about dx over x, to ln x over plus c, this is just the same as this. We just use the variable x and u here, because if we let x u, then our integrand here is just the same as our integrand here. So that's all. We have our next example. We have v dv over 6v squared minus 1 dv. So if you know the use of substitution, then you can just solve this equation, this problem. So we cannot use v as our u because it will give us v derive v, it will just give us du over is equal to dv. So we cannot substitute the value of dv here, just du. So we will not get the answer. So let u be our denominator, which is 6v squared minus 1. So if you can see now, you get the answer. So if we derive this, we'll have 6v dv. So as you can see, we have here v dv, and we have here in our integrand v dv. So we can now substitute the value of v dv here. So let's just cancel our 12 din. So now we just need to substitute the value of v dv here, which is du over 12, and our 6v squared minus 1 is u. So if we put 1 over 12 outside our integrand, we have now our answer. So we just need to follow the formula and we will get the answer. And our u is 6v squared minus 1, and don't forget the plus c. So if you derive this, you will get this answer. And if you integrate this, you will get this answer. So that is our final answer. Now let's move on to our example number 3. We have dx, xl, and x. So how do we solve this problem? So as you can see, we have x dx. We cannot use because we have her function ln x. So what we need to do is use the u substitution to get the values, so we can substitute it to our integrand. So we have let u ln x. So we know that the derivative of ln x is just 1 over x dx. So if we derive this, we have du over 1 over x dx. So now, you can just substitute dx over x here, du, and now your u is ln x, so u. So, this now refers to this logarithmic formula for logarithmic integration. So now we just need to follow the formula, which is the value of integrand of du over u is equal to ln u, our u is ln x. And don't forget the magical c. This is now our final answer. So if we integrate this function, ln, we will just get we know that the the derivative of this is du over u. So ru is this. So we just integrate. Du will have 1 over x dx. So we have, and just copy the value of u here. So we have 1 over x times ln x times dx. So we have our derivative. This is just the same as our integrand here. Don't confuse yourself when solving problem like this. If you can use u substitution, you can solve any logarithmic function.
Hace que te extrañe y quiera volver a empezar.